We are evaluating an integral with one infinite limit. So we're going to replace the infinite limit with one finite value, a large x, as an upper limit. And then we're going to take the limit, x tends to infinity, provided the limit exists. So we're looking at a rational function, so let's rearrange it, and then we can integrate it. So when we've integrated, and remember the chain rule as well, dividing by 3 there, or multiplying by 1/3 is fine too. We put in our boundaries, our limits there, x and 1. Simplify it down. And as I said already, we're taking a limit x and it tends to infinity, so it's going to 0. So we're going to find this value now. So we're replacing the x with what we have there. And of course, we end up with 2/3 at the end. And that's the answer for that. In part B, we are looking at a volume of revolution. It's the same function. It's rotated through 360 degrees about the x-axis, and we have our boundary values of 2 and 1 for B and A. And we have a formula for this, but just before I do that, let's have a look at the diagram that I'm doing there. So just thinking about this shape as it goes down, and we'll actually have a 3D cone almost. So a cylindrical disc is what it's called. So you can deal with discs and washers and all these kind of things. But basically you just want to kind of do a reflection of the shape. And from there we can use that formula. And again, I'm just getting y squared there on the right hand side. And from there I can use the formula, which is pi y squared. So integrating that. And from there it's pretty much straightforward in terms of what you've been doing with integration once you've solved that. So we're obtaining the value for the function, as I said, using this formula. I'm just rewriting that in a way, just to make sure it's clear. You can put pi out the front. It's a constant, so it doesn't really get involved. Of course, putting my dx's there. Don't forget that. From there we can integrate. And when you've integrated, you can simplify by plugging in the boundary values that you were given. Don't forget the chain rule there as well. Once again. And so that's simplified down. And now our boundary values are 2 to 1 on the x-axis. And now, therefore, we can plug in the value for x. So inside here with 3 times x minus 2. And when you get that final value, it's 5 pi over 32. Okay. The normal to the curve on the point x and y are 1, 1. It crosses the y-axis, so x is equal to 0 at the point A, and find the y-coordinate of A. Okay, normal tells us that we'll find the perpendicular gradient. So negative reciprocal, we call it, those kind of things. Let's just find there, as we see, the derivative. Again, chain rule times 3, and you'll get minus 9 over 2, and then that last part. Remember, it's minus 5 over 2 there for the exponent. Okay, that's our derivative. So from the derivative, you can find the gradient. So when x equals 1, dy over dx should be, of course, minus 9 over 2. Because there won't be any values left. And, of course, a negative reciprocal. So the perpendicular gradient for normal will be 2 over 9. So if you were to multiply both of them together, you get minus 1. Okay, from there, the equation of the normal. So we have a value for x and y. So y minus 1 is equal to 2 over 9, bracket x minus 1, close bracket. And then, of course, that first part we were given at the top was x equals 0. So using that information, y minus 1 equals minus 2 over 9, and of course y should be 7 over 9. And that was the last question for November 2021, Series 1.